Today I have a very special seminar from Michael Crusoe on what is essentially a new part of research, enabling informatics infrastructure, we'll call it, and I think Michael's a really good example of the sort of person that is necessary in the sort of digital age, if you like, for disciplines to remain at the world's forefront, and particularly biology, which is going through a digital revolution, as you'll be aware at the moment. This seminar has been organised courtesy of the University's Computational Biology Research Initiative and Melbourne Bioinformatics, and we hope to have more of these type of things going forward. We're very appreciative of Michael coming down to Melbourne. He was here for a different reason up in Brisbane, but he's made some time to come down to us and share what he knows about common workflow language, which is, of course, a huge amount because he invented it. So,
I'll have to give lots of clarifications. I did not invent it, but I am one of the co-founders. So a few things. This talk is Twitter friendly, so feel free to take pictures and tweet. The preferred hashtag is CommonWL. And if you like the slides, or you want to see them later, there is a short link. It'll be on every slide, and I'm sure it'll get emailed out, perhaps, if somebody wants to. So thank you for the nice introduction. Yeah, just a little bit to start with, because I'm kind of a funny person, and help understand my perspective, where I came from, a bit about me. So I'm from the Sonoran Desert, and I've kind of meandered through traditional IT and industry, kind of then went into microbiology, as one does. And then immediately got thrown into bioinformatics and had fun in the sequencing analysis world. And now I'm kind of working on this. So I speak not so many people languages, but I speak many different research languages and technical languages. So I try to bridge these. In retrospective, it was great preparation for what I do now, and it helps me kind of bridge these gaps and talk to these different communities. So feel free to talk biology at me and talk computers at me. I think usually I can follow. So before we get into like what CWL is and how it came about and what it can do, I'm just going to define some terms and set some context. So it's time for a little bit of audience Q&A. So who knows what a workflow is? Who's written a workflow? Should I define the term workflow? Yes. So workflow to me is computational data analysis. Gluing these different tools together, get things done. It's what we do day in, day out in bioinformatics. So who here's used a system that, besides working at the command line, to run their bioinformatics or other sorts of workflows? OK, cool. So lots of you. So you probably don't necessarily need an introduction to like what a workflow system is and why we might want to use them. I like to point out, though, some features that I think help bring clarity to why they matter. And this first one on separation of concerns. I think this is really the key point. There's lots of pragmatic, useful things about workflow systems. But really the goal here, or the big benefit here, is this, being able to think about the data analysis I want to do, the research I'm doing, the science, and then be able to have a separate conversation, maybe with different people, about running that at scale, about the operational aspects, about making it run faster. So to me, this is the core. Workflow management system, whether it's Galaxy or something else, needs to do that very well. I always kind of come back to this. There's other nice things, right? We're doing our research. We get it's easier to run all these things. Maybe we'll get a graphical user interface. And I think not all systems, but the good ones will give us this provenance. They'll tell me the story. How was some file I made? How did I get that? Because it's, we do a lot of work. We make lots of files. We might forget all the time which one came from where. So, because sometimes when I give these talks, people aren't really sold that we should use workflow management systems. But I think once we reach a level of complexity in our research, we should, these things provide a lot of value. So now that we've all been convinced, even if we weren't already, that workflow management systems might help our managing our computational data analysis, we might go shopping for workflow systems. And I've been collecting lists of all the things that scientists and researchers use in bioinformatics and other fields. It is a very incomplete list. It is a very long list. This screenshot that is blurry is out of date. I'm up to 121. I'm sure I'm undercounting by probably a couple hundred, or maybe 1,000. There's a long tail of research workflow systems across the disciplines. So you might see that there's a challenge there, right? We have all these different systems, people use them. How do we collaborate and cooperate across them? And if you have used or written your own, there's no shame in that, but I'd love to hear about it. So please, you can tell me about it, or you can go make an edit directly in the wiki. Because there's lessons and different approaches made in all these. So it's useful to kind of collect that. So this is why we start thinking about standards or common languages, right? Researchers are going to use all sorts of different workflow management systems or not. They're going to try to collaborate within their institute, within their region, across continents, and on a good day, across disciplines too. And we need a way to transmit and collaborate across our different infrastructures. So has anybody here worked on an ISO standard or a national standards body? So you may have heard about this. And so you might have had some weird feelings about a standard. Sometimes people are like, oh, it's going to slow things down. They never match, provide what people need. I'll have to just implement this thing that isn't actually useful. So that's like the bad side of standards. I actually think that standards can be really useful, and that a good standard enables this collaboration and even innovation in workflow systems. So the Common Workflow Language doesn't aim to stop any system from doing a new thing and innovating. We work really hard to enable that. And we just need to accept that no one's going to, in maybe a small sphere, you can get people to agree to use one system, but once you go global, it's just not happening. So we need to be okay with the fact that people use different systems. And funders and journals are not going to generally say, go use a single system. They're going to want a standardized approach. They're not going to want to be kingmakers, decide who wins. Many times I talk to people about this problem. They're like, well, this is not a problem. You should use system 122 that I wrote that solves all of these issues, right? Like the old XKCD comic about this. But this is not the reality. We need to be able to have interoperability. So what is the Common Workflow Language? It is not a platform, right? It's not that platform number 122. You don't install, buy, purchase the Common Workflow Language system. You would use a platform that has CWL compatibility. We ran this as a community-based standards effort. It's very extensible. So if we give a formalized schema and specification for the platform so that they can ensure that they're meeting the compatibility. And we've really designed for a variety of computing environments. So lots of people like cloud stuff, great. Lots of people don't. Lots of people use their laptop or an academic computing grid. The data model we use does not require the use of any of those systems and is sort of aware of the differences. However, people do like cloud and containers and Docker, and we support that in 1.0 as a first-class way of doing things. But that container space is evolving over time. There will be things in the next few years, and we will support those as those come out. So I was introduced as would you call me the inventor? This started at the Bioinformatics Open Source Conference a couple years ago at the Code Fest. Yeah, you were there. Yeah. And there was just a bunch of idiots at a whiteboard saying, this might be a bad idea, but let's try. So I was one of them. We also had Peter Omstutz from Curaverse, John Chilton from Galaxy Project, and Wojciech Jajanic from Seven Bridges. And then along the way, we've picked up a lot of friends from all sorts of other neat places that are have contributed to or informed our understanding about or are making use of CWL. Recently, the Netherlands Open Science National Plan said we're going to use CWL for workflows because interoperability matters. So I think that's kind of neat. And we're here to make something that's useful. And if you think we did something useful, try us out. And we always love more partners and friends to help us improve and become more useful. Also, Elixir has been doing a lot more with CWL as well. In fact, my current time is co-funded between the Elixir Hub and Rob Finn at EBI for at least doing a short contract that they're both participating in. So 1.0 was released last year. Support is growing, but it's still new, right? So you might kind of want to ask yourself, should I use CWL now? Should I do another approach? And I'm not really pushy about this. I think people should do what works for them in that moment. So if you really need to collaborate across institutions and infrastructures, if you think you need to preserve this workflow across time, and you want to come back to it and be able to compare, so there will be changes even within your own local infrastructure, or you're moving to a system that happens to support it, I think that's a great time to use CWL. If you're just still figuring out your research, maybe you're writing code or still putting together programs, go do, there's some complexity here, so go do something simpler. That's not wrong. I'm not here to tell you you have to use CWL and anything else is wrong. But this could be, because right now you're going to have to write some code by hand. But soon, I think probably at BOSC, a bunch of graphical editors and other support tools are coming out. That's going to make this a lot easier. So CWL isn't hard, it's just different. So if you've got something else that works, and you don't meet these other things that CWL does very well, this portability, interoperability, that kind of long-term maintenance, it's okay. You don't need to use it right now. You should do something that's useful. But it's nice to know what's available. One thing I like about CWL is I like to develop on my laptop and my text editor and my terminal, maybe on a remote machine. That's how I work. And there are other folks who have access to these systems with the graphical user interfaces, and we can collaborate over that. So that's like a fun thing for me. So it's a feature I like to point out. So I just want to talk about the principles, about the design, how we did this, some of our values. And there will be some on-screen examples of CWL, and I'll walk through that. And by the way, we can do questions at the end or during the talk too, so don't be shy. So in designing this, obviously, so we came together as the initial group was software engineers, myself from the tool author and user perspective, and the other three from a platform perspective. So we certainly cared about, there's no good having a standard that nobody implements. It's too complicated or asks too much. We had some core use cases we always want to care about, especially, since I had a bit of a Galaxy background. Being able to have, generate a graphical user interface for a tool or workflow, converting that the data model and the file format is rich enough to be able to convert between CWL and other things, or to generate tool or workflow descriptions programmatically. And learning from other examples like web standards, we knew that people were going to extend it, so we decided to embrace change. So we have a way of that we ask people if they want to go do something that's not in the spec, they're going to add a new feature. We kind of ask them to do it in a certain way, so it's very obvious. It doesn't get in the way of them innovating, doing a new workflow feature. It still allows them to be compatible part of the ecosystem. In fact, that's actually now how the standard is going to grow. Before, we would change the spec, and we'd have to update our code base to catch up to that. And now we want them to innovate, prove out these new ideas, and then we're going to pull them into the standard. We also really care a lot about linked data. And I'll give you an example here in a moment about what that is. And of course, pragmatism. We're here to get things done. Things actually have to work. So who's worked with linked data? Anybody? Oh, not so much this crowd. Yeah, RDF, ontologies, vocabulary. So one thing about CWL is it's not specific to any discipline or domain. You will find no words that are unique to bioinformatics in the specification, though we all came from bioinformatics to begin with. But we still need to refer to these concepts and whatnot. We want to be able to plug this in. So let's say we're describing file formats, right? We want to make sure, it's like in Galaxy, we'll do this, right? The tools only can link up if the file formats match. But in Galaxy represents a lot of that in code. Well, it turns out a project called EDAM has developed this way of talking about this standardized vocabulary to talk about bioinformatic file formats and data formats and tools and processes. So when we're working in bioinformatics, we can plug EDAM in to our CWL descriptions, and I'll show a concrete example in a bit, so if this seems really abstract, I apologize. So that allows that community, so they can go innovate, because in bioinformatics we have lots of secret file formats, subfile formats, and they have all those relationships in their ontology. If you're familiar with Galaxy, they have all those relationships in code. So this allows us in the standard to plug in these other standards. So we want to play nicely with them. So we can imagine other fields can and are doing the same thing. So we all get to grow together. So this isn't, CWL is not the bioinformatics standard that only bioinformatics will use. Though we came from us and we experienced the pain the most and had the most experience. But it really, we're starting to see its use across disciplines. Digital humanities, radio astronomy, cheminformatics, some other cool places. So I mentioned some of the design goals, but I also want to talk about some use cases we're already seeing. There's this idea around publication reproducibility. People talk about that a lot. I personally find reproducibility to be necessary and terribly boring. I don't really care. Ooh, you got the same result. Okay, you should be able to do that, of course. I care about reuse, right? So we remember way back to my intro slide, I worked in a lizard lab, and nobody works on lizards, and so we don't really care about reproducing results from other disciplines. We want to take their cool ideas and analysis and play with our own data. Reuse matters. So we really do focus on that, and we're seeing this happen. We're seeing this collaboration across geographies. Already there are contests and challenges that to participate. So these like a dream challenge. We know about these? No? So a dream challenge, it'll be a goal and some test data. Go put your tools together, maybe they're your code or somebody else's. And then the old way, you would submit your results. They kind of trust you, right? And then some newer dream challenges, you would submit your Galaxy workflow, even better, but a bit system specific. And now some of these challenges, you'll submit your CWL description of your data analysis. And they'll actually run it on the real data to make sure you fully describe what you've done. And then this last bit, I don't know if anybody's doing this yet, but it seems to be a pretty good idea, is sending your compute to your data. Maybe it's an optimization, or maybe you don't want to fill out all the paperwork on this non-public data quite yet. And you want to either get a full result or at least see, is there something of interest there? Before I enter in negotiations to get access or talk to my legal department to approve restricted things. So I hope to see more of this. And the G4GH has a little working group that has an API for remote submission of CWL tools and workflows. And they do nice work. So I should probably replace this slide, and hopefully a month or so, with presentations from this year's Bioinformatics Open Source Conference. But here are the CWL presentations from last year. So I really invite you to go to the URL, and you can go and click through and read about some of these very early adopters. But now let's get into some real details what this looks like. This slide, which of course is unreadable, is to give you a feeling of the level of complexity that people are doing today with CWL. Now, personally, I don't want my workflow to look like this. I prefer using sub-workflows and nice labels to make it a little bit more readable and comprehensible, and we support that. But I like this one because it gives you a sense of what can be represented. Both of these images, by the way, were made from a University of Manchester undergrad student made a CWL viewer. And this is another advantage of standards, right, is you have an ecosystem. People can go and innovate and add value to it. And so this is a workflow. I'm redoing EBI's metagenomics workflow from their custom in-house Python scripts and whatever sort of thing that we're all familiar with into CWL. And if you use these orange boxes are sub-workflows. That's kind of a neat feature. Any workflow could be a step in another workflow. And allows for, you can kind of see through and think what's conceptually happening here, and then you can dive in and get the details. So this is the benefit of visualization. All right, so I just want to give a big shout out to a lot of folks who helped us write the standard itself. But let's look. I could talk about process, but let's look a little bit of code. The short story is we're running this as an open science, open source project, which is not like how a lot of standards are written. And if you want to read more about our values, luckily it turns out somebody else wrote them up and gave it a name. We were kind of already doing this. And then one I like to point out is voluntary adoption. Like, I'm not here to tell you to use this. I'm here to say I think we did something useful. Okay, hey, we get a look at some code. Woo! Yay. Yeah. So big feature, no XML. Yay, no? Yeah, okay, yeah. No dig on other systems and other choices in the path, but this is the choice we made. We found that YAML, which is the basic file format here, which is like JSON but with less quotation marks and curly brackets, and can have comments, which is I think, a failure of JSON, the JavaScript object notation. So we chose YAML. Sadly, I don't have a plugin for Vim or Emacs yet to give them the nice colors, but I will step through this and explain what's going on here. So who's used samtool sort? Yeah, okay, cool. So it says the comment command we use in sequence analysis. And I'll go through these steps, but first I mentioned the pluggable link data. So CWL is ignorant of bioinformatics concepts, but we can plug in the EDM ontology. We even give it a shortcut. We even say which exact version and where to get that. And later, we'll be able to use this EDM shortcut to refer to these outside concepts, which means this great team, which is like on GitHub and nice to work with, you can go add your new bioinformatics file format or whatever to them and not wait for a new release of the CWL standard to include that information. So this is like a design decision. So it's independent development so we can all progress together faster.
Michael?
Yeah.
Back to your previous slide.
Yes.
Those EDAM format
Yep.
labels are less friendly than just saying what the name is. So you have to be obliged to put a comment there.
Yeah.
Is there a way to have a symbolic name for it?
We asked for that, and they reminded us that it is true. The ideal identifier doesn't have meaning in the identifier name. So an example of this would be an ORCID, right? The whole point is that person might change their name, so that shouldn't be there, or that could be confusing. So they're right on that. But I pointed out, well, if we link to the version, then we could have a short name that was more meaningful. So we
synonyms.
Exactly. So we asked, and they're working on it, and it's probably going to happen. In the meantime, yep, I don't memorize that 2572 is the BAM file format. Well, actually I do because I give this talk too much. But I always write myself my little comment. Yeah. So hopefully they will put the synonyms in, or maybe they did and I just didn't notice. For example, they're on release 1.17, so I guess I should go look. But yeah, clearly from a usability perspective. So that's actually a nice point. I'm going to show you some syntax, but most people working with CWL never see this, right? Most Galaxy users never see the tool XML and the workflow XML. So as a design decision, we tried to make it as friendly as we could for people who have to work at this level, but we fully expect most people won't be working at this level, right? You'll be in a GUI, there'll be, because I don't want to write a workflow by hand, I would rather click and drag and connect things. But for right now, a lot of people will be working with the syntax, so that's what we'll look at for these next few slides. So at the top, we say which version we're using. Today, we're going to describe a command line tool pretty quickly. We always support documentation to help the humans and to generate user interfaces. I mentioned Docker and containers, so just briefly, right? Docker is a way of containerizing software to speed up installation and sharing. It can assist with reproducibility, but there's some challenges there. So since it's pretty popular, we allow folks to say, yep, if you want to install a software that this description is related to, here's a way to find it. And here we put it as a hint. This is actually a demonstration also of where extensibility could come in. So we could imagine a system, if they want to add an extension to CWL, the syntax, this is where they'd sort of declare, oh, I've added an optional extension, it'll go under hints. Or maybe I've made something fundamentally really different, and I have a section called requirements, just to kind of flag from the outset that I'm doing something a little bit different. All right, so let's look at, so the whole point of what we're doing here in this example is we're describing how to run a program, right? We need to go from, because then we'll piece them together and form a workflow. So we think about how we run it ourselves. We're at the command line, and we'd sort of piece together our components. We'd take our inputs, we'd represent them on the command line. So it's all about how do I go, what are my inputs, what are their types, how do I get them onto the command line? So the samtool sort command is pretty straightforward. It's going to take in a single thing. Here I gave it a label, because some human beings might read this, so we'll help them out. So it's not input 1. I'm going to call it align sequences. And I'll use that edem thing to specify the file type. By the way, if you've registered your file format with the IANA media types, which is sometimes called MIME types, you could use that too. Or something else, right? Other communities might use something else. So now we know what the input is, and then how is that going to end up on the command line? We call that concept input binding. Here it's pretty simple. The file name goes on the first position on the command line. So we just input binding position 1. These are all your weird tricks, like prefixes, or maybe there's an array, separating things by commas, or spaces, or colons, whatever the program kind of does. We can handle basically anything that, say, Galaxy can. I'm sure there's a program out there that we can't handle, and I would say that that program is too complicated, and you should fix the program. There is really a limit at the complexity here. And even then, we could probably still handle it. It just might not be very clean. So I'm just stepping back for a second. So we're going to take this bit right here and actually make a command line out of this. So I pulled some of those out from the previous slide. So we've got our input section, the base command, which is this. We're going to run samtools and then sort. And then the user, this is conceptually what they provide. So if they use the reference implementation right now in the command line, they would write this little YAML snippet. But maybe if they're on one of the CWL platforms, they're just clicking through dialog boxes to select their inputs. So command line binding is the process of taking that input object, the list of inputs, the base command, smushing it all together to be the equivalent of what we would type at the command line. So here it's pretty simple, right? samtools sort, and then the path to the file. This syntax is just to remind, especially those who work in Unix, right, that command lines are an array of strings.
Well, what are the differences between the type keyword and the class keyword for each file?
Yep. So it's the same. In some ways, you can think of the input section as a schema that specifies what is valid input. So this is a specification, and this is an instantiation. Again, should users see any of this? I really hope not. Yeah, this should be covered by some sort of interface. But some of us need to work at this level, so we try to make it somewhat, yeah. It's a good question. So that was obviously very simplistic, but just to give a starting example, tomorrow we're going to go in lots more detail. So now we've run our command. Now we get what it did out. So one way to think of this whole process is we're taking this command line program, we're really sort of turning it into a function, inputs and outputs, like we're in programming. And in this instance, it's pretty straightforward. samtool sort, its standard output stream is the output, so we can use a nice little shortcut. We'll even be nice. We'll tag it again with that. I should put the comment, the BAM file format again, because it does output again a BAM file. All right, so we just did a command line tool. And, but this is not the common command line tool description language. It's the common workflow language. So let's look at our workflow. And so for us, we think about workflows. We model them, it's data flow, right? We have steps. It's not step 1, step 2, step 3. It's a particular named output from one step goes into a particular named input of another step. So it's data-driven or data flow. I mentioned a workflow could be a step in another workflow. We do some parallelism with scatter-gather. Many people ask for, and we don't have, is conditionals and looping. Folks are working on that, but it is not currently in 1.0. But you can accomplish lots of that in other ways. So this is going to be, I'll walk through an example workflow. It's in 2 columns, just to fit on the slide. The first thing to notice is that we're going to run 2 commands, and they're defined in external files. So we're going to use the Unix grep command to search a file, and the word counting command to count the number of lines. And I'm not going to show you these, but they're just like the ones we looked here, just in external files. So just know that's what's going on here. And I'll step through this, and there will be some arrows to kind of explain what's going on. Oh, there are the arrows. OK, so, so before we did class command line tool, now we're class workflow. And just like the command line tool, we'll have inputs and outputs. These inputs and outputs aren't very creatively named like the last one. They're just pattern in files. So this is a string of an array of files with a single output. And this time, we're using a feature that in 1.0 is optional. but probably in a later release will be mandatory for platforms to implement. And so we have to declare up front, while it's in the standard, there could be platforms that don't implement it. So we have to declare up front that we're using this optional feature part of the specification. And I'll explain how scatter works here real soon. So the order of the steps doesn't matter. I gave them nice names. They happen to correspond to the name of the underlying file, but it could be more conceptual, right? Like I could name this name find stringing file, and it happens to be using the grep CWL description. Coincidentally, though, the order they are listed here is the order you would actually run them. And so you sort of infer the order based on all these connectivities. So each step has inputs and outputs. We call them in and out, just to disambiguate from the overall inputs and outputs and the per steps. So we're saying, well, the grep step, it's the description's over here in this external file. Here's how you map. The in-section is here. Here's how you map the requirements for that step. Where are we going to get that from? Well, it's pretty simple. The pattern comes from the workflow level pattern input. And it asks for a single file, and we're going to pull it from, oh, wait, we have an array of files here. How are we going to make that happen? And this is where we use our scatter feature. It's going to run this tool multiple times for each file in the array. So it's going to scatter over the in-file parameter. So it'll actually only get fed one file at a time. And so that's how we can take a tool that doesn't know about working in parallel to work in parallel. Obviously, the grep command, you can run in many files. This is a toy example. So it's going to produce, could produce many, many outputs. We can imagine tools that produce hundreds of outputs. Maybe we only care about 3 of them. And maybe it's on a remote system, but we don't want to copy all of them back. So the out section allows us to name which of the outputs we actually end up caring about. So it's a nice little optimization hint there. Because in the next step, the word counting step, which only has one input, we'll use to point where it needs to go, we'll use the step name and the name of the particular output that we actually care about. So grep, so the word count is going to use the out file from the grep step. And so scatter works is, so grep takes one file and produces one file. Because we did scatter, that is automatically going to get turned into an array. So word count, in this toy example, takes in that whole array of files. We'll produce a single output file, and that gets referred to from the output. Okay, yeah, a little complicated. Again, we don't really expect users to be looking at this. There are graphical editors, more being formally announced probably in the next month or two, available. And hopefully someday Galaxy, right? Galaxy's great graphical editor will support CWL. But if you find yourself looking at the syntax, this is just a basic intro. Questions?
I'll pop a little question, sorry.
It's okay.
So more and more it looks like a programming language to some extent, which is fine. And programming languages have some things that are useful, like libraries.
Yeah.
And I anticipate that lots of these things will be done before.
Yeah.
So can you just import some grep thing and...
Yeah, well, and in some ways this is, right? Because this grep.cwl is like the equivalent of this. It's a whole separate file describing that. And you can use, a workflow can be a step in another workflow. So we really designed to enable this modularity. You can also import and include snippets from other files. We tend to use that for custom types. Could be cleaned up some, but that's what we're doing now. Yeah.
So
Though we don't want it to be a full programming language.
Yeah.
Yeah, so these constructs are useful, but it's explicitly declarative. It's not a domain-specific language. We think it'd be nifty to have domain-specific languages with all those comfortable shortcuts, right? No importing EDEM or whatever, all those, like Nextflow, right, is a workflow system that has a read pair, paired read files as a built-in data type. So convenient and comfortable, right? Galaxy also provides a lot of that comfort because they really target those things. So any of those could be compiled down or converted to CWL, and we think that's a great idea. Because that could be more comfort for users who do still want to work textually.
Right. So that's on the command level.
Yep.
The next level up is workflows, where they, as you say, they can be nested, and that's a nice abstraction, you can say. Yep. And programming languages have, I mean, when things get big, you get name clashes and things, so you want sort of name spacing and things like that too.
Sure. Yeah, there's sort of implicit namespacing and scope levels. So we don't, I mean, because you're right, it's not any random out file. Did I lose my laser? It's not any random out file. It was the one from the grep step, right? So we do, yeah. Mm-hmm. We try to manage all that. Okay, go forward. So Carol Goebel gave me this phrase, free as in puppies. Yeah. So good things sometimes cost money. And so stuff I think about a lot since, I didn't mention my title. I gave myself my own title. It's community engineer. So I make technical contributions and I kind of engineer the community. And so the thing I spend a lot of time working on is sustainability, how we're going to make this grow and scale and training and whatnot. So these are some challenges. And though with challenges can come opportunities. So I mentioned publication as a use case. And as a, I don't know what I am anymore, but at least as a former practitioner or bioinformatician, that idea of, getting the paper, not relying upon the details they decided to include in the materials and methods section, but really having all of the necessary computational details there. And not even just there, but not even just reproducible, but reusable. That's the dream. And it's going to take a lot of work, because that's mostly a social problem. There's a related standard called the researchobject.org, which is more this data container. So here's some output, here's a figure, a table, a file. Here's the story of how it came to be. Here's who did the work, the attribution. Here's the workflow. In the current version of the standard, they have this abstract workflow representation. Well, CWL will give them that portable, executable representation. And we've agreed to work together, that we're still working on figuring out funding. But it also includes all the metadata. What was the story? What was the? It's a single framework to talk about. Okay, here's this raw data file. But no, what was the serial number of that machine? Who was the technician who did the library prep? And this is a general standard that's not discipline specific, but again allows plugging in these per discipline, minimal metadata standards or vocabularies. So it really has all the technical pieces to become a global standard across the sciences. So this is the big vision. It's going to be a lot of work. It's where we're moving. It's what gets me excited. So that's where we're going. So what's next? We're starting, we actually don't have a formal entity to own the standard. We've cleverly kept it out of the hands of the universities because they try to commercialize things. And that could kill a standard. So that's happening hopefully real soon. The tooling is getting better, more implementations are coming, and like I said, integration with research object for metadata and other goodness. Thank you all so much for your time and coming to this very quickly organized talk. I hope you found it useful. Questions? Comments? Critiques? New person. All right.
I had a question about you said these things happen in parallel, and you're saying you're scattering.
Uh-huh.
I was wondering, and I was also looking at your directed graphs, and I was wondering how is kind of support of which tasks can be run concurrently up to the implementation? Is there any sort of support for here are the requirements?
Yep.
And like don't try to open 100 files at once.
Right. Yeah. So we really do rely upon the implementations to know the environments that they're in and do the right thing. We try to enable them in the data model to have enough information to make good decisions. But sometimes out-of-band configuration is required for performance reasons. And some of that we will try to standardize more and bring in, but in the meantime, it's going to be out-of-band. So it's maybe sort of strictly, maybe it's just like slow by default. It could happen that it just breaks by default because it overwhelms your system, but like I would say that's a platform that should know about the limitations of the system it's on.
Is there anything to specify in your tool that like this thing uses a lot of memory to open?
Yeah. Oh yeah. So you can give runtime. Yeah. There's so much I didn't show in the spec, and even actually there's a lot you can do that's not in the user guide. So just if anybody's been looking at that, it's very incomplete. There's lots of cool stuff. We'll go through the cool stuff tomorrow. But there are these resource hints. You can say, you know what, yeah, I'm multi-threaded, so give me some cores, reserve them, but I can't do anything more than Like 5 cores, too many. I won't make use of it, right? And so, likewise, you could have those sort of. That makes sense. That's about the tool. Though some of the limitations you're talking about are about local system stuff.
Well, you need to have both,
Yeah.
really.
So we can on the tooling and the workflow side, we've got constructs to talk about them.
Yeah.
But there could be something like we don't have anything that to say I need a GPU, or you should run me using NVIDIA Docker, so because I'm using Docker with a GPU, for example. So then that's sort of out of band, or people can develop their own extension as a hint or as a requirement saying, yeah, don't even do this without this particular GPU type. So, but that's not in the standard right now, but we don't get in the way of people doing that. So you can always have these local or system-specific extensions.
A related thing is like slow memory requirements that we have to tell you.
Yeah. So again, if your tools descriptions have those hints, and they can be like fixed numbers. What I didn't show is sometimes you can use JavaScript to generate a value in the data model, and so some people are able to model their resource requirements based upon the inputs and their metadata. How cool is that? I mean, we've talked about this for Galaxy for years, and I'm always like, yeah, somebody should get a doctoral student on that because it'd be a great little machine learning project. So this really informed us in CWL. We did that. We allow for people doing that. So like from like KHMRAN, like my old project, if we knew the number of unique k-mers, we can actually tell you how much memory you should take, and maybe it's going to schedule faster in your cluster, and everybody's happier. But FASTQ files don't have metadata, right? So this kind of informed my contributions to this. That's why we had this unlimited metadata. So if your file format doesn't support metadata, you can still have it at the CWL layer and pass it around, and it will stay with the file. It works. There's some cleanup we're going to do to make it easier. And, well, I'll go into that a bit tomorrow.
You've got embedded JavaScript,
No,
runtime decision
If
making.
that runtime decision making sounds like a conditional, which we certainly don't do. There are areas in the spec to produce a particular value under certain circumstances. If the platform decides to support it, you can use JavaScript. It is not the Galaxy Python exposes too many details, which is not a dig on them. It's just we learned from their experience that that wasn't a good idea. So it is an optional part of the spec. We see it as it's really useful right now because we're very young and there's some things we didn't quite get into the standard yet. So you can use it to work around things. But we watch to see how people use it. And already we've seen, oh, this pattern that they're doing, let's make that a construct in the language itself. So we use it to extensibility and learning. Ideally, there'd be little to none down the road. So maybe down the road we'll learn about those things we need for modeling. Maybe we'll pull that in to the spec, so there's less and less JavaScript or not. Most people don't use much JavaScript or any. I almost barely never mention it because I kind of, if you need it, it's there, but I'd rather people didn't know it was there. Yeah.
If there's not.
Just check. Anybody else? Cool. Anybody? Okay.
So I'm a big fan of declarative specifications. I quite like that idea. And separating concerns from specification and execution. I wonder, so it's mostly syntactic, this standard that you have, but some people have to implement it, and the implementers then have to decide what the semantics is, what the meaning is of when you run the pipeline.
Sure.
And have you thought about trying to describe a semantics for CWL such that we can, because I think you have a reference implementation anyway that says this is what, but it would be better not to say the meaning is whatever the reference implementation does. It would be better to say.
So there's a formal specification, a formal schema, and a separate set of conformance tests. The reference implementation has to pass those. It is detailed enough you could derive, and we probably will when we rewrite stuff, large swaths of the reference implementation from the spec. I mean, we use this, and there are other full separate code-based implementations as well. There's one in Java, there's one in Go that they're still coming up to speed. So you're talking about the semantics of workflows as workflow concept, or you're talking about semantics of ideas within the workflow?
Not the semantics of workflows.
Yes. Yeah.
But perhaps not operational semantics necessarily, which might be too detailed.
Okay.
you can have a declarative semantics, which is more of a logical specification that says if you implement the workflows,
Yeah.
like it gets complicated when you have scatter and those sorts of things, right?
Yeah.
So you could potentially have a higher level semantics that says this is what we think the workflow should mean,
Yeah.
and your implementation to be conformant should
Yeah.
obey with that.
So we proved that out. I mean, we have that in prose, we have that in the schema, but to prove it out, we have conformance tests. Yeah, we probably could increase the coverage of those, but we try to be disciplined every time we find little quirks in the implementations. If there isn't a conformance test that clarifies it, we'll actually use that process to add that and bring clarity.
Yeah, so I guess what I'm saying
Yes.
is the prose is good,
Yes.
but prose is hard to deal with.
Of course.
And it's debatable what prose means.
Exactly.
And
Well,
you could take it one step further and say it's
Exactly.
formal semantics. for this.
In some ways, it's a bug if there's something in the spec that is testable that we don't test in the conformance. I know that our coverage is lower than it should be. But yeah. But we got 1.0 out, so we can then do all these things. So 1.0.1 was just a few clarifications. I could have released last month, but we've been busy with some things. 1.1 with a couple small new things. Probably will take another couple months. But there's no like crazy 2.0 necessarily coming. I think we've got a pretty good solid base that people are just working with now for a bit. Yeah, so we definitely do think about this issue of that the reference limitation isn't the only, like, in fact, we try not to make it too powerful, A, because it increases that code-based complexity and maintenance, but B, like, it's not meant to, we're not trying to be a platform.
So I guess where I'm heading with this is sort of when things go right in
Yep.
pipelines, that's the easy bit of the semantics.
Yes.
Where things get complicated is when you're doing things in parallel and all sorts, and something goes wrong in the middle of that.
Oh,
And
error
what-
handling.
Yeah, exactly. And what CWL says an implementation is supposed to do in that circumstance, like does the whole pipeline fail, or does that bit of branch fail, or
We have some language about that, but it's right now it's not like there are ways to say this is a temporary failure, this is a permanent failure at the tool level. You can even write some JavaScript that evaluates what did happen and say, no, this is not good, and fail right there. But at some point, that does become very implementation specific, right? Because maybe people will come up with ways of saying, this can fail, but keep going, which is a little weird. But some people like that in their workflows. So we don't have a construct for that. I've heard of that pattern. But that could be an extension for now. So it's always this kind of, I'm trying to standardize communication between platforms. I'm not necessarily trying to standardize, or we are not at all trying to standardize the platforms, the entire experience. Not trying to take over the world.
for Bernie answers.
yeah.
Yes.
I have several more questions.
Does anybody else have a final before? Yeah, please.
Well, this might be too detailed for you to discuss today, maybe tomorrow. Really interested in your metadata handling and integrating with research object level.
Cool.
And the idea that this will allow you to carry metadata through steps of workflow
Yes.
for the same next version of the different files.
Yes.
Is really great, but when it comes down to practicalities of even specifying metadata for that sample level,
Yes.
it can just be hugely complicated and very experiment specific. And
That's fine. Yeah.
I'm wondering if you're developing some tools that could be used just for that purpose. So modules that could be taken out of the CWL and used.
Cool. So a couple of the points. So preview on the metadata situation. We have the unlimited metadata concept, but then we forgot to put in constructs to make it easy to do the propagation. It's still possible, but that didn't make it into 1.0, so my bad. But there's still ways around that. It's a high priority, and I wrote that in a bunch of grant proposals. So hopefully those will get funded, and I will add those ASAP. But you can still kind of do it. So the wiring, right? Because you could imagine step takes in 5 files, outputs 10. How does the metadata flow? You need to specify that. About the different fields and the different ways and the different subfields and different experiences of representing that metadata, that standardizing those models should not happen in CWL, the standard. So we really promote this networks and networks approach that should happen at the community level. We just want to make it possible. So but there's probably some interesting ideas there. I would like to talk to you about that later. Yeah.
Maybe we can take those up tomorrow.